Hello students, how are you all? I hope you all are doing good. So I am Aditya Jain from askIITians. So today we are going to discuss a beautiful topic from your class grade 8, which is chemical effects of electric current. Chemical effects of electric current. Okay, so let's start without wasting any time. Okay, so if I talk about one general thing we have all heard from our elders in our home, that our elders recommend us to not touch the electric wires or switches in our home with wet hands. Yes or no? They don't allow or they recommend us not to touch the electric switches with the help of wet hands. So what is the reason for that? There is reason for that which is hidden in this topic, chemical effects of current. Okay, the reason behind that is hidden in this topic what we are going to discuss today, which is chemical effects of current. Okay, so the theme is clear that we are going to study something different, which is chemical effects of current, that is concerned with that advice. Then don't touch the switches or electric wire with the wet hands. Clear? Okay, so let's start the lecture. What we are going to study today, let's see which topics we are going to start today. Okay, so this is electricity or chemical effects of current. So today we are going to discuss some topics which are here as follows. Introduction. First we'll see introduction, then see conductors and insulators. Then we'll talk about electric current. Then we'll talk about some components of electric circuit. Then we move with liquid conductors. This is the main theme of this chapter, liquid conductors. And then we'll end the lecture with the topic electrolysis. So this is the most important topic. Electrolysis. This is the basic, I can say the hero of this film, chemical effect is electrolysis. Okay, so this is the most important topic, electrolysis. Okay, so let's see what you can see in this picture. There is a battery or a cell. Normally we call it as a cell. It is connected with a bulb, and there are two materials basically. There are two materials basically. One is of copper, another one is of wood. So what you can see in this picture, whenever I am touching the two wires with the copper, which is the copper, see, when I am touching with the copper, the bulb is glowing. See, the bulb is glowing. And now if I touching this wire with wood, it is not glowing. So it is something to relate with the conduction of electricity or conduction of current. Yeah, it has something to do with the conduction of electricity or conduction of current. So let's first see introduction, that what is basically current. Current is the basically, if I define the flow of electrons, okay, so whenever electrons flows through any material, then that is known as current. Okay, so current will only flow when there is some movement of electrons inside a material. Yeah, that material can be a conductor, yeah, or that metal, or that material can be made up of different types of materials as well. Okay, so see in this picture there are some electrons flowing like this. Okay, so whenever there is particular direction of electrons, because if you see in this left picture, there is some random motion of electrons. So in this case, no current is flowing basically. No current is flowing or no electricity is there. But if you see in this right picture, what you can see that there is a particular direction of movement, or particular movement of the electrons. Yes or no? This is the particular movement. So whenever there is some particular movement of electrons, or the flow of electrons is in a particular directions, then we can say the current is flowing or the electricity is present in that path. Okay. Now see about two types of materials which we are concerned with, conductors and insulators. So some materials will allow the passing of current or electricity through them easily. For example, copper and aluminium. Whatever electrical wirings are present in our home is copper and aluminum only. Why these are used? Because they easily allow the electricity or the current to flow through them. So those materials which easily allow the flow of current or electricity through them are known as conductors. And those materials which do not allow the flow of current or electricity to them are classified as insulators. So these are two types of materials, conductors as well as insulators. Okay. So if I talk about some conductors, conductors anticipate free flow of electric current because electrons are present in them, or I can say free electrons are present, because the basic necessity for flowing of current is that electrons should be flowing. So in conductors, electrons are free to move. That's why they are easily able to conduct the current. While in insulators, no free electrons are present basically. That's why they are not able to easily conduct the current. Yeah, so you can see in this left diagram, this is insulating ceramic. This is fine ceramic. So as you are joining this switch or this wire, there is no glowing of bulb here. So we can say the current is not going through this ceramic. But if you can see a metal in this right picture, so as you just join this wire, the current starts flowing, this yellow motion. So the conductors will allow the movement of electricity through them, and insulators will not allow the movement of current or flow of current through them. Okay, this thing clear? So we have classified conductors as well as insulators. So if I give you example, basically conductors are metals. You can say all metals are good conductors. Okay, and if I talk about insulators, then non-metals are basically insulator. So all metals are conductors and non-metals are insulators. The only exception here is graphite. All you have heard about graphite, you use your pencils. So that nib of pencil is made up of graphite. So graphite is a basically form of carbon. Although it is a non-metal, but it is the only exception that although it is non-metal, but it is a good conductor of electricity. That is the property of graphite. That's why I've mentioned it as an exception in non-metals, that graphite is a conductor. So I hope conductor and insulators are clear. What is the basic difference between any conductor and insulator? Okay. Now see what is electric current. I already mentioned whenever charges flow will take place, okay. Now what is happening in the electric current? If you see the previous slide, I have told you whenever the movement of electrons is in a particular direction. Okay. So can I say something is forcing them to move in a particular direction because before that they were moving in random direction? Yes or no? So something is forcing them to move in a particular direction and then only current is flowing through the material. Yes or no? So what is the force which is making them to move in a particular direction? Is the energy. Is the energy provided from outside. So you are providing some energy from directions and then only current is said to be flowing. So that energy is given by a device which is known as cell or battery. A cell or battery. So cell or battery is a source of energy in the electric circuit where current will flow. So electrons require energy in order to move. So energy comes from the electric cell, or you can say battery. Okay, so what is cell or battery? It has basically two terminals, positive and negative. Okay, battery or cell has two terminals, positive and negative. You all have seen a AA type cell, triple A cell, A cell. So these cells are having positive and negative terminals. If you carefully observe any cell, if you buy from the market, which is used in basically TV remotes or AC remotes, then what will you observe? There are two terminals basically. There are two terminals, positive and negative. Okay, so the symbol we use for cell or battery is like this. This longer line is the positive terminal and the shorter or line is negative terminal. So this is the basic symbol for a cell. Okay, and what is battery? Battery is combination of various cells. Battery is a combination of various cells. So I hope this is clear. What is electric current? How electric current will flow? Energy is provided by the cell or battery, and those materials which allow the current to flow, conductors, and the opposite one are insulators. Okay, all metals are conductors, all non-metals are insulators except graphite. Done. Okay. Now next is electric circuit. So what is electric circuit? If I simply define electric circuit, is that the path that the current takes to move, the closed path. If I precisely define this as a closed path that current takes to conduct electricity. So that closed path will be known as electric circuit. Okay. So what is electric circuit? It has some components also. It has some components that electric circuit is a closed path that current will take to conduct the electricity through that portion. Okay, so that is defined as electric circuit. Done. Now see what are the basic components of electric circuit, because this is important. What are the components of electric circuit? So here you can see two diagrams. One is the circuit diagram, another one is pictorial circuit diagram. So if I make necessary things for a circuit, that it should be having a cell or a battery which is providing the energy, because then only current will flow. It should be consisting of wires, and it is consisting of a bulb, and just like this. And this portion is known as a switch. So circuit can be having two conditions. Either circuit should be closed or circuit can be open. So when this switch is open, as you can see, when the switch is open, the path is not closed. Yes or no? If the switch is open, the path is not closed or the loop is not closed. So current will not flow. Current will not flow in that case whenever the circuit is open. So open circuit is the situation when the switch is open. And when this switch is closed, just like this now, what you can see, the circuit has been completed. Suppose this is the closed condition. This is the closed condition. So in the closed condition, what you can see, that current has got the closed path to flow. This is the closed condition. So whenever the circuit is closed, current got the path to flow, or I can say closed loop to flow. So whenever the switch is open, current will not flow, no current. And whenever the circuit is closed or switch is closed, current will flow. Current will flow. This thing is clear. Okay, so this is the circuit diagram. This is positive. Positive is showing the battery's positive terminal. Negative is showing, or zero is showing the negative terminal. So actually the figure is like this. This is positive, this is negative. Current starts flowing, and if you know, current always flows from positive terminal of the battery. This is the basic thing or important thing you have to remember, that current always flows from positive terminal to the battery and ends at negative terminal. Direction of current is positive to negative, and from the convention, you can also remember that flow of current is opposite to the flow of electrons. So that is another important point. I already told you, whenever electrons will flow, current will be there. But the direction of current will be always opposite to the direction of flow of electrons. So suppose in this circuit, current is flowing from positive to negative. So current always flows from positive to negative terminal. So if current is flowing like this, the motion of electrons will be like this. They are moving in this direction, anti-clockwise. Yeah. If current is flowing in clockwise direction from positive to negative, then electrons are supposed to flow in the anti-clockwise direction. So that's why the direction of current in the circuit is opposite to the direction of flow of electrons. Clear? And when the switch is closed, current will carry. When the switch is open, circuit is incomplete, so current will not be there. Okay. So if you can see in this pictorial circuit diagram also, this is on position, this is off position. So whenever you are turning this switch to on position, bulb is glowing. See, on position, bulb glowing. When it reaches off position, bulb is not glowing. So that is the thing for having an electric circuit or for having the current to flow. The circuit should be closed, not open. So this is electric circuit. So what are the basic components? Cell or a battery. What are the basic components of electric circuit? Cell or a battery. Wires are also required that are conducting. Yeah, not insulating. So conducting wires are required. Bulb is required, and a switch is required. So these are the primary requirements for electric circuit. I think this is clear. Okay, now we are coming to the main question that I was asking you, that in your childhood your elders were recommending you or suggesting you not to touch the electric wires with your wet hands. So suppose if I take the basic example, we have already seen we are attaching a battery to a bulb. This is a bulb and bulb is glowing. So what is actually happening? This bulb is glowing due to the heating effect of current. This bulb is glowing due to the heating effect of current. So what is heating effect of current? That whenever a current flows through the bulb, the temperature of the filament of bulb increases. Then due to that increase in temperature, heat is released in the form of light. So bulb is glowing due to the heating effect of current. So suppose the question now arises, it is a solid, yeah, it is a solid conductor. So if I ask you a question, do liquids conduct electricity? Do liquids conducts electricity? This is the important question, that do liquids conduct electricity? So you can do experiment. Suppose what you can do, you can take a liquid solution, any liquid solution, and place the two terminals of a wire here and connect it with a battery. This is positive terminal, this is negative terminal, and a bulb is attached. A bulb is attached. So this is the bulb. Okay. So if you enter this two wires or two portions of the circuit, and if the bulb is glowing, you can say the current is flowing through the liquid. Yes or no? But if the bulb is not glowing, you will say current is not flowing through the liquid. Yeah. But it can be also a case when the current is flowing, but still the bulb is not glowing. So what will be the reason that? Because bulb requires some certain amount of current to glow, because it will require some certain amount of current to get heated, and after heating it will glow. So although liquid is conducting electricity, it is not conducting in that much amount that it will be able to glow the bulb. So what to do then? You can use a different device to measure. You can use a different device to measure the flow of current. One such device is known as LEDs. LEDs glow even in small amount of current. Even in small amount of current. So whenever the amount of current flowing through a circuit is less, then also LEDs will glow. So they will show you whether the current is flowing in the circuit or yes or no. So the basic answer to the do liquids conduct electricity is the yes. Yes, liquids do conduct electricity, and they conduct electricity by the process which we are going to study under the topic chemical effects of current. So whatever current liquid is conducting, this is due to the chemical effects of current. Clear? Yeah, done. So this is due to the chemical effects of current. So this is due to the chemical effects of current. Done. Sorry for interruption. Yeah. So chemical effects of current is concerned with the conduction of electricity by the liquids. Previously, in earlier classes, what we were observing the flow of current through solids. Now the question arises, do liquids conduct electricity? Yes. So that liquids conduct electricity is due to the effect of current, which is known as chemical effect of current. So this is the main theme of this chapter, that liquid conducts electricity. So if I give you some name, that sugar solution, honey, kerosene, and petrol. Sugar solution, honey, kerosene, and petrol. These four are poor conductor of electricity. Poor conductor of electricity. Poor conductor of electricity. So why I am saying them poor conductor of electricity? Why not insulators? Because every solution conducts some amount of current, electricity. Yeah, it will carry some current, but yeah, the thing is that it is a poor conductor of electricity, that it is not generating, or it is not allowing the current to flow in that much magnitude or in that much amount. So that's why I'm saying that poor conductor of electricity or good conductor of electricity. Whenever we define liquids, we define them as good conductor of electricity or poor conductor, not as conductors or insulators, because every liquid solution contains some amount of or conducts some amount of current. Okay, so that's why we are using the word poor conductor of electricity in place of insulators. So these four solutions never conduct electricity. So who will conduct electricity? All solutions of acids, bases, and salts. So all solutions of acids, bases, and salts will conduct electricity. Will conduct electricity. Okay, so all solutions of acid, bases, and salts will carry or conduct electricity. That is the basic phenomena. So what is the reason of conduction of electricity here? Because these solutions of acid, bases, and salts having something known as ions. They are having something known as ions. So what happens whenever a solution decomposes? Whenever a solution decomposes, it gets decomposed into two ions. Basically, one is positive, one is negative. These are basically ions. So whenever a solution breaks or a liquid solution breaks or decomposes, it generates two types of ion. One is positive and another one is negative. So due to the generation of ions, there are now some free charge carriers present to conduct the electricity, because in the earlier case of solids, electrons were the reason for conduction of electricity. Yes or no? When we are talking about solids, but now in liquids there are ions generated which are positive and negative. So that will decompose, solution will decompose into that ions, and due to the presence of such ions, positive and negative, conduction of electricity will take place through liquids. So this process is due to the chemical effect of current, or this process of conduction of electricity by liquids is due to the chemical effects of currents. Okay, so the theme is clear. What is chemical effect of current? That liquids will conduct electricity due to the chemical effect of current. Okay, certain chemical reactions are taking place in the solution. That's why, due to the chemistry of that chemical reactions, it is getting decomposed into positive and negative ions. So the basic chemistry behind this is this chemical reactions. Done. So solutions of acid, bases, and salts will conduct electricity due to the presence of ions. Now, if I ask about water, do water conduct electricity? Yes or no? Do water conduct electricity? Yes, given by elders to you in your childhood. Then never touch the electric switches or wires with wet hands. Wet hands means hands having water on them. Yes or no? So water is a conductor of electricity. So if you touch the wire or touch the switch, current will flow through you. Okay, now imagine what will happen if current will flow through you. Okay, you can imagine the situation. So that's why elders recommend us not to touch the wire with wet hands, because water is also a conductor of electricity. Which water I am talking about? It can be a tap water, it can be a rainwater, yeah, any type of water. So why these waters are carrying or conducting electricity? Because they have some minerals in them. They have some minerals in them. Due to the presence of those minerals, they are conducting electricity. But what about a thing which is known as distilled water? What about a thing which is known as distilled water? Do distilled water conduct electricity? No, a big no. So what is the reason here? What was the process or phenomena responsible for conduction of electricity in liquids? That they should be having some ions in them. If I talk about distilled water, it has no minerals in it. It is free from minerals. Pure water. Pure water. Distilled water is a pure form of water. Pure form of water. Okay, so if it is a pure form of water, it contains no minerals. If there are no minerals, there are no ions present to get decomposed. So there is no conduction of electricity through distilled water. So the thing is clear. All solutions of acid, bases, and salts will conduct electricity except sugar solution, honey, kerosene, and petrol. Okay, all metals are good conductors, all non-metals are bad conductors or insulators, except, yeah, okay. So the concept is clear. What is chemical effect of current? So the answer that do liquids conduct electricity is yes. Done. Okay, now next. This is liquid conductor, some basic liquid conductor. You are observing some vinegar solution, yes or no? You are observing some tap water. So these are the conductors of electricity. How you can see the conductance? You can see a deflection here. So what is actually happening here? Since I told you that bulb is not sufficient to measure the amount of current flowing or to measure the presence of current flowing through the liquid solution. So what you are doing, either you can use LEDs or you can use magnets. You can use magnets because there is something known as magnetic effect of current. There is something known as magnetic effect of current. What is magnetic effect of current basically? What is basically magnetic effect of current? 1 second. Yeah. So what is basically magnetic effect of current? That whenever current flows through a magnet, it gets deflected. It gets deflected even by a small amount of current. It gets deflected even by a small amount of current. So that small amount of current which is flowing through this solution will give a deflection in the magnet. So So the deflection will confirm the presence of current. The deflection will confirm the presence of current or conduction of current through the solution, liquid solutions. So that is the thing. Okay, what is here? You can see a battery here. You can see a battery here. There are two electrodes. It is dipped in a solution. Now the bulb is glowing. Glowing. You can use that metal also. Liquids are conducting less electricity, or liquids are yeah. So we were discussing the topic electrolysis. We were discussing the topic electrolysis. Okay. So electrolysis is basically made up of two words. Yeah. Electrolysis is made up of two words, electro and lysis. Yeah. Electro and lysis. So this electro is electricity. Electro means electricity and lysis means breakdown. So electro means electricity, lysis means breakdown. Okay, so electrolysis is a process involving the breakdown of solution. Electrolysis is a process involving breakdown of liquid solutions. Due to that breakdown, the conduction of electricity will take place. Due to that breakdown, conduction of electricity will take place. Okay, so if I go by the definition first, what is electrolysis? Electrolysis is defined as a process. It is defined as a process of decomposing ionic compounds into their elements by passing a direct electric current through the compound in a fluid form. So the cations are reduced at cathode and anions are reduced at anode. This thing is clear. So if I go deep in this topic, electrolysis, what is basically electrolysis? See, this is a liquid solution present here. Okay, this is a liquid solution present here. It is composing of two types of rods which are known as electrodes. Okay, and what is electrolysis? Or this is known as electrolytic solution. So electrolytic solution is something which is good conductor of electricity. Yeah, it should be conducting the current so that it can be break into ions. So good conductor of electricity. So electrolytic solution is something which is good conductor of electricity, and it has two rods which are known as electrodes, and these are connected to a cell or any device. Yeah, these are connected to cell or any device, or it can be connected to battery. Okay, so the electrode which is positive or which is connected to positive terminal is known as anode, and the electrode which is connected to negative terminal of the battery is known as cathode. So the electrolysis process is the breakdown of the solution. So suppose this electrolysis solution is present. Once the current start flowing in the solution, this solution break down into two ions, positive and negative. The solution will break down into two ions, positive ones and negative ones. Okay. So what is the ability of these ions? If I say negative will get attracted towards positive and positive ions will get attracted towards negative. Yes or no? So these negative ions will get attracted towards anode. So these are known as anions. These are known as anions which are getting attracted towards anode. And what are these positive doing? Positive are attracting towards negative. Negative was cathode. So the ions which are getting attracted towards cathode are known as cations. So thereby name goes as cations, anions, cathode, anodes. So I think you are getting confused. Although in my school days, was also getting confused. What is anode? What is cathode? What is anions, cations? So for removing that confusion, I'm giving you a trick that don't panic. Yeah, don't panic by electrolysis. This is the trick. Panic. So panic is showing positive is anode and negative is cathode. Okay, so positive is anode, negative is cathode. So the trick lies behind this word panic. So positive is anode, negative is cathode. So never get confused now. Positive is anode, negative is cathode. Clear? So if anode is positive, it will attract negative ions. Yes or no? If anode is positive, it will attract negative ions, and that negative ions will be called as anions because they are getting attracted towards anode. And what is cathode? Cathode, negative is cathode. So if cathode is negative, it will attract positive ions towards it. So that positive ions which are getting attracted towards cathode will be known as cations. So this is electrolysis, very important process. We will also see application of electrolysis in the next lecture. So electrolysis is shown by liquid solutions. Some basic examples are NaCl. If I am talking about electrolytic solution, one is CuSO4, H2SO4. So these two CuSO4 and H2SO4 are in your course. These CuSO4s and H2SO4 are in your course. Although NaCl will also show the process electrolysis. So the basic process electrolysis is clear. How to remember this? Don't panic. Don't panic. Clear? So electrolysis is the process of breakdown of the solution into ions through the conduction of electricity. That is known as electrolysis. So I hope this process is clear. Okay. So what we have learned today, we have learned electric current. Yeah, we have seen what are conductors, insulators. Those who will allow the current to flow through them are conductors, and the opposite ones are insulators. Then we talk about the question, do liquids conduct electricity? Before that, we also learned what is electric circuits, closed loop, components of electric circuit, cell or battery, bulb, connecting wires, and switch. Circuit is open, current will not flow. Circuit is closed, current will flow. Then we move towards the liquid conducts electricity. Yes. Solutions of salts, acid, bases will conduct electricity. Okay. Then we move on to the important topic, electrolysis. So don't get panic. This is the trick. Don't get panic. Positive is anode, negative is cathode. Anions, cations, breakdown of solution. That is electrolytic solution. That is electrolysis. I hope these are clear. Now the question is, which instrument is used to detect the nature of charge? So there is an instrument which is known as electroscope, which is used to detect the nature of charge. That what is the nature of charge? It is positive or negative. So electroscope is an instrument like this. It consists of a metal rod. Here, this is metal, and it is consisting of a gold leaves. These are two gold leaves. So whenever, suppose you are touching a positive charge here. So if this is positive, this positive charge will flow through this metal because metal is a good conductor of electricity. Both the gold leaves will get positive charge. And if these both are positive charge, they will repel each other because like charges repel each other. That's why you are able to find the nature of charge through the electroscope. Clear? So you can name the device used to measure the charges, electroscope, or detect the charge. If these get deflected, you will answer that the charge is present. If they are not deflected, you will answer there is no charge present, because if there is no charge in the substance you are interested to study, then current will no charges will not flow this metal knob. And if charges are not flowing, there will be no charge present on these leaves. So there will be no deflection. So deflection is showing presence of charges. And if deflection is not there, there is no charges present. Okay. Now how charging is done by induction method, or how is charging by induction method used in real life? So the real life example, if our induction is what? Induction is the process of charging without touching. Okay. Just by placing an object nearby to another object, you can transfer the charge. So that is the process of induction, that if you are placing some object or conductor near to another object, it will get charged without physical contact. That is due to the process which is known as induction, because you are inducing the charge on another body without any physical contact. That is clear? So that is known as induction process. The basic example is wireless charging. Wireless charging is helping you in day-to-day life with the process of induction. Clear? Now, what is the potential difference? Potential difference is the energy basically. Potential difference is the energy given by cell or battery. Given by cell or battery. So the energy given by cell or battery is known as potential difference. So it is being asked that what is the potential difference between 2 points having potential this and this. So this is a basic mathematics question, 4.5 minus 2.3. Yes or no? So you will get 2.2 volts. So this is basically the potential difference between 2 points. So potential difference is something you can remember as the energy given by the cell or battery, because energy was required to make the flow of current through the circuit. Clear? So I hope All concepts are clear. So the important one was electrolysis. An important answer was that liquids conduct electricity. Tap water, rainwater will conduct electricity, but distilled water will not conduct electricity. So I hope today's lecture was enjoyable. Yeah, very knowledgeful. So thank you so much. Stay safe and enjoy. We'll end the lecture today. Thank you guys.